Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have an isometric 3D projections of a solid in which this is the front face, this one it is the top face, and this is the right hand side face of the solid. So all these three faces, they have been combined in this 3D isometric projections in a single view. Now we are required to draw the three orthographic projections of the solid, that is the front view, the top view and the right hand side view of this solid needs to be obtained. In order to develop the orthographic projections, now we are required to evaluate the dimensions of the front view face, top view face and the side view face. Now when we look at the solid from the front side, so the width of the solid happens to be 30 millimeter, height of the solid happens to be 30 millimeter. So the front view face of this particular solid will be appearing as a square having an edge equal to 30 millimeter. Now when we look at the solid from the top, then the width of the solid happens to be 30 millimeter and the depth of the solid also happens to be 30 millimeter. So just like the front face, so the top view face of the solid will be again a square having edge equal to 30 millimeter. Now when we are viewing the solid from the right hand side, so we observe that the depth of the solid happens to be 30 millimeter and the height of the solid is also equal to 30 millimeter. So therefore the side view face, it is also a square having an edge equal to 30 millimeter. Now let us evaluate what are the surfaces which will be viewed when we are going to look at the solid from the front view, top view and the right hand side view. So whenever we are going to look at the solid from the front view, so we are going to observe three surfaces over here. So the three surfaces, they are surface number A. So this is the surface which has been marked as A, and then the second surface is, this is the surface C over here. Second surface which will be viewed from the front view will be the surface C, and finally we have this surface E over here. This is the surface E. So these are the three surfaces A, C and E, and since all these three surfaces, they happen to be parallel to the vertical plane which will be located over here, so the projections of the surfaces A, C and E, as they are obtained on the vertical plane in the front view, they will be appearing as true shapes of these surfaces. Now when we look at the surface from the top, so we are going to view two surfaces over here. This is the first surface which is the surface which has been marked as F. So this is an angled surface, and this surface, it is parallel to the horizontal plane, right? So the projection of the surface F onto the horizontal plane in the top view will be viewed as true shape, whereas this is the slanting surface, surface G. So this surface G, since it is inclined to the horizontal plane, so its projection on the horizontal plane will be viewed as the apparent shape or the shortened shape over here, right? So we are not going to obtain the true shape of the surface G onto the horizontal plane in the top view. Now when we look at the surface from the right hand side view, now please check, we have to look from this side, right? So once we are looking at this particular solid from this side, so this is one square face we'll be able to see, right? So this square face will be visible to us as the object line because we have got this square face facing the observer over here, whereas these surfaces, that is surface number D, surface number G and surface number B, that is they are lying on the back side of the solid over here. So these three surfaces, so they are not visible to the observer from the orientation from which the observer is going to look at this particular solid. So we are going to get one square which will be drawn with the help of an object line, and then the projections of the surfaces D, G and B onto the profile plane over here. So they will be represented as dotted line or the hidden line projections over there, right? So the only surface which will be visible from the orientation or the position of the observer, it will be a square face, whereas these faces now they are lying on the back hand side. So we are going to get hidden line projections corresponding to surface D, G and B, and over here also surface D and surface B, they will be parallel to the profile plane. So the projections of the surfaces D and B, as they are obtained on the profile plane, they will be true shapes. And again, surface marked as G, so this surface is still inclined to the profile plane as well. So the projections of the surface G onto the profile plane will be appearing as the apparent shape, right? So this will be giving us the reduced projections or the shortened projections of the surface G onto the profile plane in the right hand side view. Now let us start evaluating the orthographic projections of the solid. So the XY reference line we have drawn, then the X1, Y1 reference line also has been drawn. Now this is our transfer line which will be used to transfer the distances from the top view, that is along the depth direction, onto the side view over here. Now since we are required to draw front view, top view and the right hand side view, so the front view will be drawn above the XY reference line, the top view will be drawn below the XY reference line, and the right hand side view will be drawn on the left hand side of the front view, right? So let us start evaluating the front view. So we know that the width of the solid happens to be 30 millimeter, right? So this is the width of the solid. So we have marked this width equal to 30 millimeter. So these projection lines corresponding to the width we have also carried forward or extended onto the top view projections, because we are going to require this dimension of width even in the top view. Similarly, the dimension corresponding to the height, this projection line which is corresponding to the height, so this will also be required in the right hand side view. So this height projection line has also been extended onto the right hand side view, right? So front face of this particular solid has been drawn. It has been drawn as a square of edge equal to 30 millimeter. Now let us draw the depth of this particular solid along the top view. So this is my depth of the solid which I have drawn in the top view, and we know that the depth of the solid also happens to be equal to 30 millimeter. Now the width is 30 millimeter, depth is also 30 millimeter. So in the top view we have obtained the top face projections as 30 millimeter by 30 millimeter square over here. Now let us transfer this depth using this transfer line onto the right hand side view. So in the right hand side view, once again, the depth of the solid, it is equal to 30 millimeter. It has been marked in the top view. The height of the solid, it is also equal to 30 millimeter. So this height has been marked in the front view of this particular construction. Now let us start with the front view. Now as we are going to look at the solid from this side, so this is the side from where the front view will be observed. So we have evaluated that there is this edge, that is the left corner over here. So we have to move 5 millimeter above the base so that this slant edge bottom point will be located over here, right? So this is the slant edge of this particular solid corresponding to the surface G. So it is starting from the top. After you move from the rightmost corner 10 millimeter towards the left corner of the solid. So this is the rightmost corner of the solid. As we move along 10 millimeter towards this side, so one point, that is this point, will be located, and from this point we have to draw a slant edge corresponding to the surface which has been marked as G, and this is the bottom point that I am talking about right now. It is located at a height of 5 millimeter from the bottom, and this is corresponding to the left corner. It is corresponding to the left corner of the solid 5 millimeter above. So I will be getting the bottom point corresponding to the surface G. So this will be available as an edge view in the front view over here. So this is my first projection line which I have drawn. Now the next one, as I told you, this is slant edge. So this slant edge of the surface G, it is going to start from the top as I move along 10 millimeter from the rightmost corner that at the top towards the left side over here. So from the rightmost corner at the top, it is this point over here. I have to move 10 millimeters back over here towards the inside. So 10 millimeters I have moved towards the inner side of the component. So I have been able to obtain this point, right? So once I obtain this point, so the vertical projector line I have drawn over here extending onto the top view, right? So this will give me this side or edge of the web over here. So this is the web which I am having at the top. So this web is having uniform cross section of 10 millimeter, right? So on this side it will be the width, whereas on this side it will be the depth of the web over here. So this width equal to 10 millimeter I have been able to mark in the front view. So having marked this, now I know that this is the slope of the surface G. It starts from a point which is located 10 millimeter from the topmost right corner, and it will be ending up at a point which is at a height of 5 millimeter from the bottom. So this inclined surface G, we have been able to obtain the edge view of this particular surface G in the front view, right? So the edge view has been obtained over here in the front view. Now the second thing is, please check, I have got the surface C also. So the surface C is, it is going to start from the leftmost corner, and then as I move along the base 10 millimeter towards the right side of this particular solid. So from the leftmost corner I have to move 10 millimeter towards right. So from this point I have to move 10 millimeter towards right, right? So once I am moving from the left corner 10 millimeter towards right, so I have to draw a vertical projector line over here, because in this case only this edge of this particular cross section corresponding to the surface C has been given, whereas there is no indication about the height of this edge corresponding to the surface C. So this will be obtained automatically once we move 10 millimeter towards right. So whatever the height is appearing over here, so this height automatically will be evaluated over here, right? So this is the byproduct. So main thing is I need to move 10 millimeter towards right. So automatically this point, which is corresponding to the top point of the corner C, this has been located. So once I have drawn these projection lines over here, so all the elements of the front view, they have been located over here. So let me darken the different edges which are visible to the observer. So let us start with surface A. So in the surface A, the base is visible, right? So this base, this 10 millimeter and this 20 millimeter. So this is the total 30 millimeter base which is visible to the observer. Then this is the height equal to 30 millimeter which is visible to the observer. Then from the left side as well, please check, this is my 5 millimeter height, and then this is the remaining 25 millimeter height. So from the front view, these two, you see edges over there, they will be appearing as a straight line as viewed by the observer, and then this top, this edge, that is equal to 20 millimeter, and this edge equal to 10 millimeter. So they are going to lie in a single straight line as viewed by the observer from the front side. Now let us move on to this slant edge over here corresponding to the surface G. So I need to join this slant edge dark, that is this surface G, this entire surface G, which is an angular surface over here, it will be appearing as a straight line from the front view. Now having obtained this, now I need to obtain this part, that is this edge and this edge. So these two edges, they will be again coinciding with each other, because this surface B, it happens to be perpendicular to the vertical plane over here. This is my vertical plane. So this surface B happens to be perpendicular to the vertical plane. So this edge and this edge, they are again going to coincide with each other. So once they coincide, so I have to draw this as a darkened line over here. So once I draw this darkened line, now the things, they are clear. This is my surface C. Please check. This is my surface C as viewed by the observer from the front view. Now this is my surface A. We can check the shape of the surface A over here. So this is the shape of the surface A. And then this is the shape of the surface E over here. Right? So this is the shape of the surface E. Now this shape has been observed over here. Now all these three surfaces, surface A, surface E and surface C, they happen to be parallel to the vertical plane. So these three projections of the surfaces A, C and D, as obtained in the front view on the vertical plane, they will be all representing true shapes of these surfaces. Now let's move on to the top view. In order to draw the top view, now I need to draw this 10 millimeter depth. So this is the 10 millimeter depth of this web. Okay, so this is 10 millimeter depth of this web. The moment I draw this projection line, so automatically, please check, surface F has been obtained over here. This is my surface F. So which is this surface? It is this surface over here. So this is my surface F corresponding to the, this is my depth of 10 millimeter. As I move along this side, so I have got the width of this top web equal to 10 millimeter. So this is my surface F, which has been observed over here. Now next thing is, as I can see, there is a cut over here and this is a square. We can check along the depth side, it is also 10 millimeter. Along the width side, so this cut which has been made, so this is also 10 millimeter. That is, and where does it lie? It lies over here. So please check, 10 millimeter I had already drawn. That is dimension along the width I had drawn while I was drawing the front view. So this width I had drawn while I was drawing the front view. Now this is the depth which I need to draw now. So this is my 10 millimeter depth which I have drawn at the front side. So this is the front face over here. So from the front face, I have moved 10 millimeter back and this projection line has been drawn. The moment I draw this projection line, so this cut which is there into the solid, so this cut has been obtained, which is 10 millimeter along the width. So this is 10 millimeter along the width and this cut is 10 millimeter along the depth of the solid. Now this I need to move on to the right side view also, right? So this has been transferred onto the right hand side view also. Now let us start with the remaining procedure. So this is the cut which has been obtained. So I have darkened this. Next, I know that once I obtain this cut over here, now this portion of the solid, it is visible to me. Now what is this portion of the solid? It is this edge. Please check this out. It is this edge is visible from the top, as well as this edge is also visible from the top. But these two edges, they will be falling in one line as you are looking at the solid from the top. And then once you reach here, this edge is visible, this edge is also visible to the observer. So this edge is visible, which is this one, and this edge is also visible. It is this edge over here. And then finally from the top, this surface and this surface, so they will be appearing as a straight line in the top view, because we have already discussed that this is the surface G. So even though the surface G is inclined, but it will be appearing as a straighter surface in the top view, that is the apparent shape will be visible. So this surface true shape is being observed. So this is the true shape over here corresponding to this edge, but refer to this edge of the surface G. It is a longer edge, but since it is inclined to the horizontal plane, so it will be appearing as a shorter edge onto the horizontal plane. Right now I have to draw this web, that is the surface F. So this surface F we are going to join now. So 10 millimeter along the depth and 10 millimeter along the width. So once I join this, so both of the surfaces F and G, they have been obtained. So surface F, since it is parallel to the horizontal plane, so we have been able to obtain the true shape of this surface F onto the horizontal plane. Whereas the surface G, so since the surface G happened to be inclined to the horizontal plane, so onto the horizontal plane in the top view, we are going to obtain the apparent shape of the surface G, and we can see that this surface G as obtained in the top view, it is much shorter than this particular original surface which we were able to see in the isometric projection. Now let us draw the right hand side view. So in the right hand side view, we know that, as I told you earlier, this square face will be visible to the observer from the right hand side. So these are the projections which are visible to the observer, because the observer is looking at the solid from this side. Now I need to draw the projections corresponding to the surface D, surface G and surface B over here. And these surfaces, since they are lying at the back side corresponding to the observer, so observer is situated over here, so these three faces, they are not facing the observer, they are lying on the back side of the solid. So these three faces, they will be observed as hidden lines or the dotted lines over there. So I know this cut, please check, I know this cut, this is the depth over here, so this is equal to 10 millimeter. I know the height of the surface. What is the height of the surface? It is equal to this one. So this I had obtained as a result of moving 10 millimeter towards right side as I move along this particular inclined surface over there. So this height we had observed in the front view, and the depth, it is available over here. So once we combine these two things, please check, the cut which was appearing over here has been drawn in the right hand side view. It is this surface B. Please check, it is the surface B over here. Surface B is having depth equal to 10 millimeter, height equal to this distance. So this distance we have already evaluated over here in the front view, right? So distance has been evaluated in the front. So now the surface B has been evaluated. Now let us move on to this edge over here, that is this inclined edge of the surface G. So this inclined edge of the surface G, it is located 10 millimeter from this edge, 10 millimeter from this particular edge. Where is this edge located? In the top view, it is located over here, right? So the inclined edge, it is at a distance of 10 millimeter from this edge, that is this one. Now once I project it over here, so this is going to get me this inclined edge, but then I have drawn dotted line only up to the height of 5 millimeter. Why? Because this inclined edge is to be drawn starting from the top, and it will be ending at a surface 5 millimeter above the base. So that is why we have ended this over here, and then from here this particular edge of the surface B has to be drawn, which will be again drawn dotted. So please check. So this edge has been drawn dotted over here, right? So this completes the side view. Now the three surfaces, they have been obtained. In this case, surface B, surface G and surface D over here. So we can see that all these three surfaces, surface B, G and D, they have been drawn with the help of hidden lines, that is the dotted lines, because all these three surfaces, they are not visible to the observer, as the observer is situated on the opposite side of these three surfaces. So observer is able to see only the squarish face of this particular solid. Now these are the orthographic projections of the solid. Now we are going to remove the markings that we had made onto the orthographic projections, and now we are able to obtain the better correlation between the orthographic projections which have been obtained and the isometric projection. And finally, the redundant dimensions also we have removed so that we can get the final orthographic projections of this particular solid. So this is all for today. So I hope that through this discussion you would have got better idea about how to develop the orthographic projections of the solid when the isometric projections of the solid they are available with us. So thank you very much. Thanks a lot.